Hi everybody, this is Mrs. Hayes with video note 6.5, Solving by Factoring, Day 1. And we're going to start off by looking at some equations that we've seen before to try to remember how to solve equations, because we are solving. If my pen will let me work. Okay, so find the values of x that will make each equation true. So we're basically looking for solutions to these equations. In number 1, I'm noticing that this looks like a little linear equation to me. It looks like mx plus b, and there's no squares. I'm going to subtract 3. What I'm doing is sorting. I'm keeping my x's on the left, getting my numbers on the right. And then I'm just going to divide by 2. So x is equal to 1. Now that is the value that will make that equation true, meaning if I just did a little check here, 2 times 1 plus 3 would definitely give me 5. Next question, I'm noticing x's on the left, numbers on the right. I'm noticing it's linear, so I'm going to subtract the 2x. So I have a 3x minus 2x. And at the same time, I'm going to add the 5. So on the other side, I have 7 plus 5. I'm sorting. 3x take away 2x is 1x, or just x. So the answer is x equals 12. Again, that is the answer that will make this equation true. If I check it, 3 times 12 minus 5 will be the same as 2 times 12 plus 7, just looking back at the original. That is true. Okay, this next one has a different symbol in it. This is an inequality symbol, but it's still, all the x's only have a power of 1, so I'm going to do some sorting. X minus 2x, I'm moving the 2x, and on the other, or at the same time, I should say, I'm going to subtract the 5. So I have less than 6 minus 5. Combining like terms, I have negative x is less than 1. And then to finish this off and divide by negative 1, I need to flip the symbol because I'm dividing by a negative. So x is greater than negative 1. 1 divided by negative 1 is negative 1. So if you think about this, I want all the numbers that are greater than negative 1. That would be all of these numbers, like 0 and 1 and 2. There's a whole bunch of solutions to that. All right, let's look at this next one. I see an x squared. Well, that makes things a little weird. Let's see, can I sort? Well, I already got my x's on the left and my numbers on the right. I'm not sure what else to do here. This is new and exciting to me. My first thought is to try to get everything over here, maybe to see if I can factor this. So I could have an x times x to make an x squared. I'm thinking right now about the box method and how to make that x squared and how to make that negative 1 in the corner. So this has to be a 1 times 1. So if it was a 1 and a 1, the signs are different because that's a minus 1 here. So that's a minus and a plus. But negative x and positive x is going to make a 0x and not a 2x. I'm not sure what to do about this one. I guess that's what we have to learn today. One of these things in numbers 1 through 4 is not like the other. That's number 4. And the reason is, why? It's got an x squared. It's a quadratic. The others were all linear. So we do have something to learn. When you're solving a quadratic, you're finding its zeros, otherwise known as roots, or solutions. And if you remember a quick picture of that, you're finding where the graph crosses the line on the x-axis, where it crosses the x-axis. So these x-intercepts, like x equals 1 and x equals 3, for example. All right, so what are the solutions to this quadratic function? And they showed you the graph below. So you don't have to go to your graphing calculator to solve this graphically. We're looking for solutions. They're right here on the graph. So this one is at negative 1, so x equals negative 1. And this one is at 1, 2, 3, so x equals 3. If you think about it, negative 1, 0, and 3, 0 are the coordinates of those points. So the y value is 0. The solution is x. Solve each of the quadratic equations for x, graph and check. Now I want you to do this algebraically, but we are going to do a graph to check these. So what you're looking at is you've already set this equal to 0, meaning the y is already equal to 0. So you're going to take these factors and find their solutions. You're going to find the roots from the factored form. You're going to find the roots by setting these factors equal to 0, because this product, the two things multiplied together, must be equal to 0, which means either the x plus 7 equals 0 or the x minus 2 equals 0. So you notice I made this t here to separate the two factors and do two little equations that I need to solve. Subtract 7, x equals negative 7. Add 2, x equals 2. Those are my roots or solutions or x-intercepts. If you were to graph this, you would see a quadratic. This is an x squared if you multiply it back out. And you would see zeros at negative 7 and 2. I happen to know from previous work that this is a positive smiling parabola. So if I enter this on my graphing calculator, this is what I would see. Next one. I see two things multiplied together, factors. This is again in factored form. And I want it to equal 0 when I multiply, which means either the x is equal to 0 or the x plus 9 is equal to 0. This is already solved, so there's one of my solutions. This one I need to subtract 9 to find x equals negative 9. So if I were to graph that on my graphing calculator, it would look like this. X times x plus 9, and you see a 0 at negative 9, and you see the other 0 at 0. Okay, so moving right along. To show solutions on the Inspire, you can do analyze graph and find the zeros. In that case, they were easy to find because I could see them. All right, let's look at the next page here. Question 7. Solve each of the quadratic equations for x. So we are solving, and we're going to graph to check. So they're already set equal to 0. I'm going to use factoring to get the factored form. So this is a trinomial. I've gotten good at factoring. X squared is x times x. And then I look at the 14. I could use a 14 and a 1 or a 7 and a 2. Noticing the 5 in the middle, I'm going to use a 7 and a 2. And then noticing that the negative is on the 14 and the 5 in the middle is positive, I'm going to use a positive on the 7 and a negative on the 2. Now you could certainly play around with the box method to try to figure those out. I'm just going to show you how to finish this and then look at a graph. Set each of these factors equal to 0, subtract 7, x equals negative 7. X minus 2 equals 0, x equals 2 when I add the 2 to the other side. So let's take a look at that graph. X squared plus 5x minus 14. Control back a few pages. Nope, I didn't mean to hit control. Let me just escape. Is it this page? Okay, so here's the graph. And if you can tell that the zeros are at 1, 2, 3, 4, 5, 6, negative 7 and 2, then you would have known that the factors were correct. You can also do menu, analyze graph, and look for the zeros. Set up your left bound and your right bound, negative 7, 0, and then you can do the same to find the other one. So negative 7 is your answer, x plus 7 was your factor. When 2 was your answer, x minus 2 was your factor. Okay, the next one in part B looks slightly different. If you're thinking about this form, there is no constant. It's just got x's in it, which means there's a GCF when you go to factor this. Divide each of these pieces by x, and you'll be left with x plus 5. And then you can set each of the factors equal to 0. So x equals 0 is one solution. X plus 5 equals 0. I need to subtract the 5 to get x equals -5. And if you were to graph this, you would see zeros on the graph, and it would look like this. So there are your solutions. Algebraically, find the zeros of the function. Algebraically, find where y is equal to 0. So x squared minus 12x minus 13 equals 0 needs to be factored. It's a trinomial. X and x makes x squared. 13 is pretty easy. That's just a 13 and a 1. And to get a negative on the 12, I need a negative 13 and a positive 1. Set your factors equal to 0 and add 13 to both sides. X equals 13. X plus 1 equals 0, subtract 1, x equals -1. Question number 9, find the x-intercepts. They are trying to trick you. Those are also known as zeros. And it says algebraically, so x squared minus 10x plus 25 needs to be set equal to 0. It's where the function equals 0. And this is easy to factor also. So we have an x times x to make our x squared. 25 is 5 times 5. If this is a positive, these are both going to be the same sign, and I need a negative on the 10, so it's a negative, negative. Set those equal to 0, and what you're going to find is the same answer twice. X equals 5. What that would look like on a graph means at 5, 2, 3, 4, 5, you're going to see the graph just come down, touch once, and go back up. They call that a bounce. It only touches once. It only really has one answer, 5. If you wrote it as a solution set, you'd only see one answer. It's called a double root. Sometimes you have to make y equal to 0 when solving for x. So that's what I was doing up here, putting these equal to 0. And that is actually something that you need to show. So if I were you, I would star that. You have to set them equal to 0. That's because whenever you get these answers, the y value is 0, and you're looking for the x value. These next two questions are pretty quick and easy. I just want you to find the solution, and they already gave you the function. Now this one looks like an x cubed, if you remember what a cubic looks like. That doesn't even matter. The solutions, just look for the x-axis and find where it crosses. Where is y equal to 0? So I'm just counting 1, 2, 3, -3, 0, and 2. My solutions are x equals -3, x equals 0, and x equals 2. This one, you don't know this yet, but this is actually an x to the 4th graph. And my solutions, there's 4 of them. So if this is 0, -1, and -2, x equals -2, x equals -1, 1, 2, 3, x equals 3, and the next one is at 4, x equals 4. All right, I hope you understand what you're doing. Factoring, setting things equal to 0, and solving is a whole lot of fun.